so let's go ahead and let's get started on the notes for today. Remember, today and tomorrow, just to review over what we did before Christmas break, just a short little quiz on Friday, and then we'll get into like the new stuff in chapter 7. So, before we really dive into the rules review for today, I wanted to take a second just to remind us what the different parts of a power are. I mentioned before Christmas break that I'm very guilty of this, that I use the incorrect vocabulary. It's really important to use the correct vocabulary. So when we're talking about the parts of a power, I know what I do quite often is I look at this thing, the 3 to the 4th, and I'm like, oh, that's an exponent, which isn't right, okay? The entire thing, the whole thing, is called a power. When you look at 3 to the 4th, you should say, look at that power. That's such a cool power. And then if we talk about the different parts of the power, the big number, the 3, is called the base. And then the exponent is just the little number. And then 3 to the 4th, we know means you're going to take 3, the base, and multiply it by itself 4 times. The exponent tells you how many times you're going to multiply the base by itself. So 3 to the 4th means 3 times 3 times 3 times 3. And then you would go ahead and evaluate that. Okay? Now, our rules that we're going to review. The first one, we talked about it yesterday. Okay? The negative exponent. Remember, we can't have a power with a negative exponent. So to make a negative exponent positive, you're going to take the power, flip it over the fraction bar. So if I had something like 4x to the negative 3rd y squared, okay, something like that. Biggest thing with negative exponents is you're only going to move the things that have the negative exponents. So x to the negative 3rd, the only thing that has a negative exponent here is the x. So when you're moving things, you wouldn't move the 4, you wouldn't move the y squared. They would stay up there in the numerator. The only thing that would move is the x would flip down to the denominator, and that negative 3 would become a positive. Okay, so that was the rule from yesterday, along with the 0 exponent. Now the other rule, this is a pretty simple rule. So this is the product of powers. So product means that we are going to multiply powers. Just talked about that. That's the whole thing. So whenever you're multiplying powers with this same base, this rule is pretty simple. You are going to add the exponents. Add the exponents. So for example, if I had 4x cubed times 5x to the 5th. It's just a big multiplication problem. I can't really do much with 4 times x cubed because I don't know what x is. And I can't really do much with x cubed times 5 because I don't know what x is. And same thing here. So what we do in our heads, we kind of rearrange it. You multiply the numbers. You take 4 times 5, which is 20. And then when you take x cubed times x to the 5th, the reason why we add, because if you were to write this out, x cubed, 3 of them, and x to the 5th, 5 of them, 3 plus the 5, you would have an x to the 8th. That's why we add the exponents there. Okay, the next rule, and these are the two that are really easy to get confused. This is the power of a power. So we have a power, raise it to another power. This is where you are going to multiply the exponents. Once again, let's explain why we multiply the exponents. If I have x to the 4th cubed, x to the 4th cubed. Once again, think about what this means. It'd be x to the 4th times x to the 4th times x to the 4th. So you have these 3x to the 4th, which is actually the last rule that we did. Multiplying powers with the same base, so you would add the exponents. You would take 4 plus 4 plus 4. But the thing is, when you take 4 plus 4 plus 4, you add 4 3 times. That's the same thing as taking 4 times 3, and you get x to the 12th. That's why we multiply our exponents. And then the last rule to review today is the power of a product. So if I have a product, a times b raised to a power to the m, okay? This one's pretty simple. Every factor gets the exponent. Every factor gets the exponent, and that should be an M, not an N up there. So everything inside the parentheses, whatever that exponent is on the outside of the parentheses, everything inside the parentheses gets that exponent. So if I have 3xy cubed, and that whole thing is squared. What this means is everything inside that's out of parentheses gets squared. Because 3xy cubed squared means 3xy cubed times 3xy cubed. You take 3 times 3, which is the same thing as 3 squared, which is 9. And you would have x times x, which is the same thing as x squared. And then you would take y cubed times y cubed, which if you were to write it out like that, you'd actually do 3 plus 3. But this is the rule, that rule, right? 3 times 2, you have a y to the 6th. Okay, those are our rules to review today. Okay, so we're going to go back. I think I forgot to put my table of contents here. Okay, so we're going to go back to the very first page. Remember, if you open your book, okay, the very first page is where you glued in the paper from yesterday. The next page is going to be page 1. So that left-hand side is going to be page 1. We won't put anything on page 2. This is going to be chapter 7, table of contents. So the table of contents is on page 1. Nothing on page 2. We are going to glue today's notes on page 3, and it's just going to be 7273 recap. All right, so number 1, 3x squared times 6x. 3x squared times 6x. Now, keep in mind with these are all multiplication problems. We shouldn't be really ever adding the coefficients, okay? It's a big multiplication problem, so I'm multiplying 3x squared times 6x, which means I need to rearrange this a little bit and multiply the things that I can multiply together. I can multiply 3 times 6 and we get 18. Now be careful here because when I take x squared times another x, this is the rule where we add the exponents, but I don't see all of the exponents. I see the 2, but I don't see an exponent here. If I don't see an exponent here, what is it? It's a 1. Just think about it. It's x squared times another x. 2 plus this other one here. There's 3 of them, so it's going to be an x cubed. 18x cubed would be your answer. Okay, number 2. All right, what if we do negative 5x cubed y to the negative 4th times 4x to the negative 5th y squared. Now, once again, it looks, I think, way more complicated than it actually is. This is just a big multiplication problem. So you're going to pick out the things that you can multiply together. I can take negative 5 times 4. Negative 5 times 4 is negative 20. I can multiply my x's together. I can take x cubed times x to the negative 5th. Now, this is the rule. I know it's different because there's a negative exponent, but this is the rule where you add the exponent. So it'd be x to the 3 plus negative 5 will give me x to the negative 2nd. Then you can multiply your y's together. Y to the negative 4th and y to the 2nd. We would add those exponents. Negative 4 plus 2 would give you y to the negative 2nd. Now, just like yesterday, we cannot have negative exponents, but be really careful here because students get really carried away. They're like, okay, I see negative exponents, so I need to move the x, I need to move the y, and I need to move the 20, which isn't quite right. I don't need to move the 20 because we only move things that have negative exponents. We don't move negative numbers. There's nothing wrong with a negative 20. We've never had to move a negative 20 ever this year, right? There's just a negative 20. There's nothing wrong with a negative 20. There's something wrong with the x to the negative 2nd. There's a problem with a negative number as an exponent. No problems with negative numbers. just negative numbers as exponents. Okay? So the negative 20 is going to stay up in the numerator. But the x moves to the denominator, and the y moves to the denominator. So we're not moving negative numbers. We move powers that have negative exponents. Okay, be careful with that. Okay, number 3. X cubed squared times x to the 4th to the 5th. Now, this is the rule where it's the power of a power. This is the rule where we multiply our exponents. And the reason why we multiply our exponents, remember, x cubed squared means x cubed times x cubed. 3 plus 3. That's the same thing as 3 times 2, which is x to the 6th. When you do x to the 4th to the 5th, that'd be x to the 4 times 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 x to the 4th. You would take 4 plus 4 plus 4 plus 4 plus 4, which is the same thing as 4 times 5, which is x to the 20th. Now this rule is the other rule, right? You have x to the 6th and x to the 20th. You got 6 of them and 20 of them. 6 plus 20 of them, you have x to the 26th. Okay, let's try a tricky one. This one's a good one. Okay, number 4. 4x to the negative 4th y squared all to the negative 2nd. Now, these are the ones before Christmas break that I told you, take them slow. I guarantee you the more work you show, the better you'll do on them. I actually think they're easier the more work you show. The first thing we need to do, this is the power, or the power of a product. Everything in here gets raised to the negative 2nd power. So I'm going to take 4 to the negative 2nd power. Now, when I take x to the negative 4th to the negative 2nd power, that's the rule that we did on number 3. This is where you're going to multiply these together. Negative 4 times negative 2 gives me x to the 8th. And you're going to do the same thing with the y's. 2 times negative 2 gives me y to the negative 4th. Okay, if you could, this is the place where I'd probably tell you that if you have an x here and an x here, let's write them as 1 power. But I don't have that. I have a 4, an x, and a y. I cannot make all of those into 1 power because they don't have the same base. So the next thing I'm looking for is these negative exponents. The 4 has a negative exponent, and the y has a negative exponent. So the x to the 8th stays in the numerator. The 4 moves to the denominator, and the y moves to the denominator. And the last thing, we would never want to leave it as 4 squared. We would do x to the 8th. 4 squared, 4 times 4 would give me 16 y to the 4th. Okay, last two. Let's kind of combine everything together here and we'll just do one more. Let's just do one more. Okay, number 5. In parentheses, 7x cubed y to the negative 2nd, all to the negative 2nd, times 4x to the negative 4th y cubed squared. Now this one, definitely, I promise you, the more work you show, the slower you take it, the easier it is. First thing, I need to get rid of these parentheses, which means in the first set of parentheses, everything gets raised to the negative 2nd power. So we're going to take 7 to the negative 2nd power. We're just going to have to leave it as 7 to the negative 2nd power. Now when I take x cubed to the negative 2nd power, we're going to multiply. 3 times negative 2 gives me x to the negative 6. Do the same thing with the y's. Negative 2 times negative 2 would give me y to the 4th. Now in the second set of parentheses, everything gets raised to the 2nd power. We're going to square it. So we're going to take 4 squared. When I take x to the negative 4th squared, we take negative 4 times 2, which gives me x to the negative 8. And for the y's, you would take 3 times 2, which gives me y to the 6th. Now once again, this is just my preference. What I would do next is I notice, well, I've got an x to the negative 6 and an x to the negative 8. There's no reason to have these two powers that have the same base. There's no reason to have two of them. I can combine those into one power, and we do that by adding the exponents. So negative 6 plus negative 8 would give me x to the negative 14. And we can do the same thing with the y's. 4 plus 6 would give me y to the 10. So there's my variables. And then I still have my numbers. I have my 7 to the negative second. Now here's the thing. You can't do anything with the 7 to the negative second. You can't evaluate that yet because it's 7 to the negative second. But with the 4, I've got 4 squared. I can take 4 squared. 4 squared is 16. Okay, now we've got some negative exponents. So the 7 has a negative exponent. The x has a negative exponent. So we'll leave the 16y to the 10th in the numerator. We'll move the 7 squared to the denominator and the x to the 14th to the denominator. And then the last thing we want to evaluate that 7 squared. So it'd be 16y to the 10th over 49 x to the 14th.